Okay, for this field trip, I'm going to go to one of the many quarries that are around the place where we get all our buildings and our roads and our bridges. So I've done a video already on how we've mined to get the cement. That's called the calcium cycle. And then you can have the fine aggregate. It doesn't have to be sand, and the large aggregate here to make up your concrete. And so they're the mines that we're going to look at now, the basalt hornfels and quartzite that's taken to make this and crushed into either large pieces or small pieces to go with the cement to make the concrete. And the closer the ratio to 1:1, that means how much pressure it can take. So the M40 is can withstand a higher pressure, that concrete, so it's a stronger concrete. And so the stuff's called blue metal. It's used all around Australia for our roads and our concrete and our paths, etc. And it is igneous rock, but it could also be hornfels, which we'll see in a second. And so if you look at a map here, you can see that these quarries are all over the place. You can see that there are these little scars in these nice lush foresty areas. Just out of curiosity here, look at all these mines here. This is the area where those Ormeau bottle trees are. Those two or 300 critically endangered trees are. And you can see that they're just destroying everything because we need more houses. Some of these are not quarries. That's a quarry. That's a quarry. Some of these scars are in order to build more houses. So maybe if we look down here, you can see they're destroying all the forest to build more houses. Maybe we should just be happy with our population and not try and destroy everything. And so Brisbane's got one too, by the way, right next to this amazing botanical gardens. They're destroying everything, but we need it for houses. And so there's a quarry here. So the one we're going to is this one here. So this is an old quarry. It wasn't a very big one, obviously, not as big as these things. And so we're going to go there. All right. Now, the one thing that was quite concerning is sort of the lack of science, really, lack of information that geology has to work off. And so what they do is they just basically have a look at what's on the surface. And if you have a look here, they've got these diagrams to 40 kilometers, but we've only ever gone over 10 kilometers like twice, maybe. I'll show you in a second. This one's inverted, sorry. So I went to here because I'm looking at possibly hornfels. So the basalt also just getting cooked a little tiny bit. And you can see that that is within 10 kilometers. But I was going to get some greenstone. I'll hopefully do it next weekend, maybe. And so these diagrams, which I'm quite used to, are a big sign that the science is really, really weak. And so this is a list. So we have only ever gone over, this is the same mine, the same hole here. We've only ever gone over 10,000 once. And this is just looking for gold. So the only reason we've gone this far is because we're trying to get gold, and that one doesn't count because it's all the same one. The Chinese have got there recently, and the Russians got there decades ago and then stopped. And what did they discover? So they only got to past 10K once, so that's one data point. And then they discovered that all their seismic waves are wrong. They discovered that there wasn't basalt at 7 kilometers. It was granite the entire way. It never stopped. And then it became way too hot, way too quick, faster than what they had predicted. And there was even plankton in granite 6 kilometers underground. So we have one data point, and it was enough to realize that everything that they thought was wrong, including all the seismic waves. And this is just at 10 kilometers. So imagine all those layers that are thousands of kilometers thick that you're taught in your textbooks. You've got to know that the science is really, really bad, okay? It's pretty important because what matters is the scientific evidence, and that's it right there, okay? So it's sort of even more reason why you need to go to the experiments and field trips, unfortunately, are what you need to do with Earth science, because that's all we've got. We're just looking at the surface things and making assumptions and extrapolations that are very, very wrong, but it's all we've got. So let's just work with it. And so this is where we're going. This old quarry here. It's actually quite a short walk. I've been there many times, but it takes me a lot longer because I've got the dog. All right, but I think I can get there in 40 minutes. So anyway, it looks like this pretty much most of the way because big trucks were taking rocks in and out and trees and stuff. So the path is amazing. And as you're going along the path, it looks quite tough, but you can actually pick a piece off, and that's what it looks like. And under a hand lens, remember this is just 1 centimeter. This 10 increments. You can see it's very poorly. The little granules are very poorly cemented together, and so that gives us some sandstone. So the whole area is sandstone. You can see here it just crumbles. That's another spot, but it just crumbles. Now, as you get close to this basalt dike or whatever it is, this little basalt outcrop, the sandstone definitely gets more cemented, and it's much tougher. You can see in the hand sample, you can see they're cemented much better together, and it is a much harder sample, and you can't break it off at all. You can't just crumble it. And then this is on the edge of the little crater thing, so it's quite dangerous to walk around it, which I did, but I don't think you could take students there, unfortunately. This is what I've been told is chert in other places, and this is the banded chert. It looks a very similar formation. Technically, it should be called quartzite, but it's microcrystalline quartz, so you couldn't actually tell the difference if you just pulled off a piece and gave it to a geologist. They'd probably just say chert straight away. I don't know if they'd say quartzite. And you can see the pieces everywhere. The sandstone's turned into quartzite. Up close, you can see the crystals, the very sugary appearance. It's definitely a metamorphic quartzite rock now. And so I think they've gotten rid of most of the quartz when they mined it, because they also take the chert with them and they sell that separately for landscaping because it looks nice. And that's where we label it there. All right. Now, there's not much basalt left. It's when you get to the black stuff, you can see that there's the sugary quartzy appearance with some layering quartz. So it's actually, I think it's cooled and then been reheated as well. So that's the Hornfels bit. And this is on the opposite side. You can see this is where you come in, the entrance, and this is where everyone goes swimming. And so you can see at the entrance is where the most basalt is. It's where all the black stuff is. I think they kept that nice and solid for the trucks to come in and out, and took it on all the other pretty much everywhere except for at the very start. And I don't know if you can appreciate, this is really high up. So that's the entrance there. They're people. That's lilies, so they're quite tiny. And so, I guess you don't have to walk around the edges. You could still just stay here. Because it's just really dangerous just walking around the edges. Okay, you can still see the quartzite, the basalt around there. Okay, so that's the nice basalt. You can see it has a nice fine black matrix. It's a nice clear simple basalt, but I think it gets to the Hornfels here. So you can see this is almost nice. Wouldn't be migmatite. It'd be certainly, it's wavy and foliated. And this one's got the sugary appearance. So that one would be Hornfels. I think that would be the magma that's being recooked, and that one's been recooked far too much, and I think it's gone up to the it's down around here somewhere, the schist or the gneiss. Okay, so there is a little bit of metamorphic rock, Hornfels, which is igneous rock. It's being baked, or contact metamorphism, so that all makes sense. And you can clearly see it. You can see the whole area is sandstone, and then it's the middle bit's basalt, and around the edges is all the metamorphic contact sandstone's been turned to quartzite, and even the basalt's been turned to Hornfels. And so that's the evidence we have. Hope you liked that.